Inflammation can be, well, inflammation. A lot of things go into inflammation to make it work and work properly. What's going on is if you got a cut or a boo-boo, a lot of things can start sneaking in. You got through that first line of defense, that physical and chemical defense, and their bacteria just going, yeehaw, and sneaking on in. Well, not only is this tissue releasing, hey, come heal me, but also saying, hey, I got a boo-boo, come help me. And when that happens, it's calling on neutrophils, it's calling on your macrophages to come along and help. And how they do it is via chemotaxis. Chemotaxis is sort of like a siren calling, going, ah! I better not do any more than that one because something tells me I'd get sued by Disney. That siren is the siren of Greek mythology, not the siren of weird thing on the top of a car, is calling to these macrophages. It's calling to these neutrophils and say, come to me. And they go, yes, master. And they allow for vasodilation, and then they immigrate in, and then they're there to eat. They go, yes, the sirens haven't failed us again. All hail the magic conch. So they come in and they, via this immigration, they sneak through this and then they go ahead and eat. Now all of this action causes inflammation or swelling. So let's go ahead and note the signs and symptoms of inflammation, which you'll see off to the right, prish. It sounds like a fun little word. And so prish. No idea what that even means, but we're going to run with it. So P stands for pain, R is redness, I is immobility, S is swelling or swollen, and then heat. Kind of makes sense that all these are happening. Redness, you're getting dilated. A lot of blood is coming here and hanging out here. So that red tone from that blood is really, really making it that nice red color. It's getting swollen. You're getting things, so these vessels are getting dilated and it's becoming more permeable. So not only are these things sneaking in, these phagocytes and neutrophils sneaking in, but other things are sneaking out too. You got liquids, you got salts, all these other things sneaking out, and because of this dilation, and it's going to start swelling. The swelling can lead to heat because that dilation, you're bringing a lot more heat in. It's also, that swelling can also cause immobility. If you're putting a lot of pressure on that joint or on that muscle, it can become really hard to start moving it. And when you're causing that inflammation, you're causing these cells to stretch out. You're causing these nerves, these neurons that usually innervate around here to stretch out too. They're not happy being stretched out. So they're going to send a pain signal. So there are a lot of signals, lots and lots of signals that can control inflammation. You got the kinins, which are found inactive in the blood, just like complement is found inactive, just like the prothrombin and the fibrinogen and all that stuff is found inactive. You're kind of getting the hint that a lot of things are inactive in your blood. Kinins are inflammatory. Prostaglandins, that one you probably heard about a lot. Prostaglandins are released from damaged cells and they can cause inflammation. Histamine, histamine, definitely heard about that one. Histamine is that allergy. Histamine is can be your friend and can also be your worst enemy. These guys are from mast cells. They're from basophils. They're from platelets, neutrophils, and macrophages. All those people can release histamines, but with the mast cells being probably the ones that are doing a lot more of the allergy histamine release. You also got complement. We can't forget complement. We already talked about him being a part of that inflammatory response. And again, it is found inactive in that blood. Now, how does it work? How do all these different things work? Well, one more time. Leukotrienes, they're also found in the basophils and mast cells, and they induce a different type of inflammation, or the different types of inflammation. And if we remember, we got vasodilation. Inflammation is vasodilation, permeability, and activation of phagocytes. Now, all these things, like the complement, the prostaglandins, really like to activate histamine and kinins. By activating those, you induce more inflammation. You induce more things to go on. So when these prostaglandins and complement activate histamine and kinin, it induces vasodilation. And the histamines and kinins induce vasodilation. These three, again, kinins and histamine being activated, will increase the permeability, and leukotrienes will also increase that permeability. All of these minus histamine will do something with phagocytes. They'll do the chemotactic thing, the siren call. Prostaglandins will induce immigration. Complement will attract and promote phagocytes, the chemotaxis again. Same thing with leukotrienes, but with a little bit of making it stickier, the outside blood vessels, the blood vessel lumen, I guess I should call it, the tunica intima of the blood vessels become more sticky and allow those things to stick closer so they can go ahead and sneak into those vessels or sneak past those cell wall, those junctions. Now, do you need to know every single one of these and what they do? Not really. You just need to know that all of these kind of just have some type of role in inflammation. Kinins, prostaglandins, histamines, complement, leukotrienes all have some type of role in inducing some type of inflammation, some part of inflammation. Now, here's an FYI that you're going to hear this term quite a bit. It's been like coined back in the media. It's called a cytokine storm. Cytokines is just a really fancy way of saying the molecules that are responsible for immunity are called cytokines. And what happens in a cytokine storm is that these things are overstimulated, or when they release something, there's an overreaction, and it can cause death. So inflammation just goes haywire. If it's in the lungs, it can cause pulmonary edema. You have made the tissues, the blood vessels and all that stuff all around the lungs much, much more permeable, which allows liquid into your lungs and causes that pulmonary edema, which was the major cause of the death of a lot of deaths in the 1918 flu pandemic. Not the flu virus itself, but the cytokine storm caused that death, most of those deaths. If you want a really good review article that I really enjoyed, it was a very good synopsis of all these different types of cytokines and inflammation and all that stuff. Follow this link. With that is inflammation, as well as the end of the second line of defense that we are talking about here in this class. I hope this has been useful, and I will see you all again soon.